My name is John Marlin. I'm a program manager on the High Availability and Storage team. I own the Failover clustering component, and this video series details many of the new features with Windows Server 2019 Failover clusters. As a recap, in part 2, we talked about a little bit about Windows Admin Center, easy to use, available every 6 months or release every 6 months, secure management. We talked about cluster performance history. We take a look at the past performance of the machine. You can look at it by hour, day, month, or year. We looked at system insights, analytics, and machine learning to figure out where things are headed as far as, an example of disks running out of space. And we talked about persistent memory, super fast storage on a memory stick. In part 3, I want to talk about cluster sets, what it is, what it does, Windows Server upgrades, and MSDTC. So, we want to talk about scale and resiliency. All of our telemetry shows 4 nodes or 2 nodes are the majority of the installations when it comes to storage spaces direct. 4 nodes is higher than 2, so I'll talk about this instance in 4. Each of these cluster nodes or clusters are totally independent of each other. You don't fail over anything between them, you don't move anything between them. Everything is its own entity. Well, with cluster sets, we can actually combine those together. So we are loosely coupling groupings of these clusters. So the easiest way to think about it is we are clustering clusters together. However, we still keep our independence of each of the clusters. With cluster sets, we are in essence increasing the cluster nodes and storage. We are utilizing a self-managed namespace so that when you deploy virtual machines, you use a single unified namespace when you deploy the virtual machines. When you deploy the virtual machines using the namespace, we'll look at, okay, which cluster nodes are the best for the VM that we want to deploy it to. Then we'll use that single unified namespace so we don't even actually have to know what the path of the machines are. By doing all of this, you have your scale and you're keeping your resiliency. As I mentioned before, each of the 4 nodes of each of the clusters are still independent of each other, but with cluster sets we have a top layer for specifying where you want virtual machines to go to. With cluster sets you can live migrate machines between clusters, and it's one simple command. You're not actually having to drop it out of the cluster, use Hyper-V to live migrate it over, and then add it to the cluster. We are not interfering with any cluster specific operations. So if you want to move virtual machines between the clusters, if you move a CSV ownership between nodes and we need to move it over, we can. If you drain a node, it'll still keep everything within the same cluster with a caveat. And the caveat, which is actually one of the features of what cluster sets can do, is, and I'll show you that a bit later. With all of this, we are in essence hyperscale for hyperconverged. Hyperscale meaning we have actually tested 1,000 nodes with multiple clusters. We have Azure-like fault domain availability sets. So you can actually create logical fault domains within your cluster set. So you could have a certain set of clusters in one fault domain, another one in another fault domain. You can mix storage space direct clusters with traditional clusters. We do not have to have all S2D or all traditional. You can mix and match. You can go all S2D if you want. You can go all traditional if you want. So what does cluster set do? Here we have, as the picture diagram shows, we have a cluster set head. That is our master cluster. When you go to deploy virtual machines, you deploy it using the master. The master then has an optimal node that it will try and create the virtual machine on and place it there. This will allow for virtual machine fluidity. You don't have to actually know the names of the clusters. You don't have to know what's available. I need these VMs here, these VMs I want to put over here, what's the names and so forth. One name, one unified namespace that we're actually using as well. So we place it on the virtual using the unified namespace, place the virtual machines on an optimal node. So you deploy a virtual machine, it may go to cluster 1. Deploy another virtual machine, it may go to cluster 2. This will allow movement between clusters without having to change the storage paths. We have with the single unified namespace, we've got this, we are identifying what storage we're putting it on, what's the storage path, and what's the share name. When we create cluster sets, there's an additional new role that came out with Windows 2019 of infrastructure scale out file server. It has the same role as what a normal scale out file server does. So it has the distributed name, but with an infrastructure scale out file server, it will actually create the shares for you automatically. And I'll show you that. One of the other things that it will take advantage of, and it's something that's available with the infrastructure scale-out file server role, is SMB loopback. This is something that's been asked about for a long time. When I say SMB loopback, it is if I have the virtual machine sitting on a cluster node and I want to specify a network path, that share is owned by the same node, that's a loopback. So it's not going to support that. So you'd have to actually specify a drive path. So C : /cluster storage /volume1 /VM whatever the VM is in the hard drives. Versus / the scale out file server name / the share /VM whatever the VM and hard disks are. Doing that allows the virtual machine fluidity. I can move my virtual machine to any other cluster and not have to worry about the pathing. Something that also that we've done with cluster sets is whenever you deploy a virtual machine to a local drive, there's a certain set of ACLs that'll be there. If you're deploying the virtual machine and your storage is sitting on a network path, there's a different set of ACLs that's used. With cluster sets, we're using the same ACLs, whether it's local or it's remote. So there's not any of this, it used to be local, now I move it to make it remote. It won't come online because the permissions are not right, because the ACLs are not right. With cluster sets, we take care of all that for you automatically. So as a demo, here I've got 4 different clusters. All the clusters have no roles. So I want to create my cluster set. First thing I have to do is create my master. This is all being done through PowerShell. So if I go to PowerShell, new cluster set is the PowerShell command that I would use. Specify what's the name of the master, what is the namespace root. If I have static IP addresses, I use static, otherwise it will create it as DHCP. I go and look at my cluster. Here's my infrastructure file server role that it created. If I look at it, there's the name I use for the distributed name. It will also automatically create the shares for all the cluster shared volumes that you have automatically. You don't have to share it out for you. If I want to add clusters to the cluster set, these are going to be my workers. These are the ones that are going to be hold my virtual machines. Add cluster set member, specify the names of the clusters. Once it's done that, you see here's my infrastructure, here's my scale out worker role. And you'll notice the only thing there is the name. It's all distributed names. And it did it for all of them. If I wanted to enumerate all of the clusters, I'll just say, what's the cluster set members? List them all for me. If I wanted to happen to list all the groups that are in all of the clusters within the cluster set, just specify get cluster group on the get cluster set command. Very simple, very easy to do. In the next demo, here's where I'm going to be creating my virtual machine. I could specify I want 4 meg of memory, at least 4 meg to be available. My virtual account, my virtual processors is 1. There has to be at least 1 that's available. And I'll use the get cluster set optimal node for VM. Specify how much memory I want to do as an example here. It's going to say, well, the optimal node right now is node 3 on cluster 2. I'll specify my name and password, because you will need to do that as you would anything else, just like logging in remotely to create a resource. Here I'm going to create CSVM1. This is the memory startup bytes it'll have. This is the name of the VHD, and I'm going to specifically specify this particular cluster for my storage. So I'll go ahead and invoke the command, and I'll create the virtual machine based on those parameters. You can also create VMs the normal way you do it, that you would do it. So I want to create the VMs here on a particular cluster. If I want to see what the shares are for a particular cluster, here's my volume 1, here's my cluster storage dollar that it creates automatically for you. Notice I did not create those, it created them for me. If you create virtual machines separately, you can register them. Here you see it, it created the virtual machine. If I look at the settings of it in the hard disk, here's the specified path. And you notice that it was a network name. If I go to cluster 2, you'll see that it's there. If I create my VMs in my normal fashion, I don't want to use it for cluster sets, I'll just create my VM as I normally would and then just simply register it. And that's all there is to it. If I wanted to say, hey, get the cluster set, where is it at? And it'll tell me it's on cluster 2. I can go to cluster 2 and do whatever I need to with it if I need to. If I wanted to move it, as I said, I want to move the virtual machine to another node in another cluster, I specify it, and it moves it. Even though it's on a different cluster that it was local, now it's remote. The network, the path of the VHD is not going to change. One of the other features about cluster sets, in a cluster, 4-node cluster, I want to say update one of the nodes in the cluster. I want to update it, so I do a drain. I drain all the virtual machines off. It will move to the other 3 nodes in that cluster. If there is not enough space for everything, then based off of some of the priorities that you may set, it will take some virtual machines down, lower priority virtual machines, to take them down to make room for higher priority. With cluster sets, we have what's known as a cross-cluster drain. And the way that it works is when a drain operation occurs, we will first move all the VMs, try and move all the VMs to the same nodes in the same cluster. If there is not enough room to run all of them, we will actually migrate some of those VMs to other clusters. This can allow, if you actually wanted to over provision some clusters, if you wanted to, you can. And a simple command with the parameter BM failover mode. With that, there's 2 options. You can enable it and allow it to fail back once the nodes come back, or enable it but don't fail them back. So in other words, I've got this. I issue a drain command on cluster 1, node 1. It's got to move all the virtual machines. In this case, it moved most of the VMs to the other 3 nodes, but there are 2 VMs that would not fit with the memory constraints. So what it did, automatically moved them to different nodes in different clusters. This is something that you cannot do without cluster sets. Windows Server upgrades. 2019 is the first version that we've actually truly supported upgrading in place the operating system of a cluster node. So we are fully supporting it now with 2019. Previous versions, drain the node, evict it, install everything fresh, add it back to the cluster, move on to the next ones. If you're doing rolling cluster upgrades, as they were with 2016, they are the same. So 2016 can add into 2019, 2019 can add into 2016, and so forth. There is a Windows Server upgrades page available that gives you the steps. Current supported options are upgrading to two versions. So you can go from, say, like 2012 R2 directly to 2019. From a cluster perspective, you can still only do 2016 and 2019 clusters together, or 2012 R2 and 2016 nodes together. You cannot do 2012 R2 to 2019. So from a cluster perspective, in a rolling upgrade fashion, you can't. But on that Windows, once you go to the upgrade page, it's an upgrade center. You see the site name, Microsoft.com/upgrade center. This is the page that you would actually get to first. 2008 R2, 2012, 2012 R2, 2016. This is your starting point. Where do you want to go to? So if I click on the 2008 R2, then it'll show me, here's all the versions I can upgrade to, or where do I want to get to. If I click on the 2012, then it'll take me 2012 to 2016 and 2019. There is a bug that we have filed because 2012 R2 is not listed there. If I click on the 2012 R2, it shows me 2016 and 2019. If I click on 2016, it takes me to 2019. Once you click on, say, the 2016 one, and I want to go to 2019, it takes you to the next page, which actually outlines all the steps. Here's all the things I want to do pre-upgrade. Then once I've taken care of all that, here's all the steps to upgrade. Once I've done that, here's all the post-upgrade stuff. There are additional notes for clusters for any additional steps needed if you're upgrading clusters. All there, all showing you everything about what's supported, what you can get to, what you can't get to, and so forth. So to walk through the process of this, here I've got a 4-node cluster. It is running on 2016. It is just simply a matter of draining the rolls off, upgrading the cluster node, moving the VMs back. Then moving on to the next node, same process. Move them off, move them back. Move to the 3rd node, move them off, move them back. Move to the 4th node, move everything off, and upgrade it. All live migrations, all no downtime. Don't forget, upgrade the cluster functional level and upgrade the VM versions so that you can take advantage of. Once you upgrade any clusters, we still remain at the functional level of what the cluster originally was. So if I was at 2016, even though all my 2019 or all my cluster nodes are at Windows 2019, we only get the feature set that's available in 2016 until I upgrade the functional level. The functional level is only upgraded automatically on fresh, brand new created clusters. So if I created a 2019 cluster out of 2019 machines, the functional level is at 2019. So I get all the features that are available for it. Same thing with the virtual machines. For MSDTC, this was something that was asked for a lot of the SQL people. We didn't forget you, SQL. We got this pushed through. So for DTC, what we did is added support for cluster shared volumes. Now DTC databases can reside on a cluster shared volume. It does not have to be a shared disk any longer. Because it's on cluster shared volumes, DTC can now run on storage spaces direct clusters, where it previously could not. It was all local MSDTC that you had to use. This is a big use case for SQL Server Failover Cluster Instances, or FCIs. And you can do it in Azure now, whereas you could not before, because there is no concept of shared storage without third party, obviously, but just straight Windows clusters. There is no shared drive, no shared storage available. It had to be on storage spaces direct. Now that DTC is on cluster shared volumes, it is a viable option now to have it in Azure. On-premise is still the same. You can do it on-premise or in Azure, or on-premises and in Azure. So, to wrap things up, we have cluster sets, virtual machine fluidity, clustering clusters together, cross-cluster migrations, automatically on drain operations once you set the values. You have Windows Server upgrades, in-place upgrades, along with rolling cluster upgrades, fully supported now in 2019. And for DTC, for you SQL folks, DTC now functionally works with cluster shared volumes. In the next part, part 4, we're going to talk about 2-node hyperconverged scenarios, some of the new file share witness features, talk a little bit about split brain and how it's a bad thing and what we do now to try and help alleviate it. Split brains are bad, and I'll talk about it then. We'll also talk about some of the new security enhancements that we did for clustering. So I thank you for watching this video.